Hi, my name is Nitsan Gadish, and I'm an Applications Engineer for Analog Devices MEMS and Sensor Technology Division. I'm here to talk today about activity monitoring in accelerometers. Accelerometers measure acceleration, so activity monitoring is a natural fit. In fact, a lot of accelerometers on the market today have built-in activity monitoring functions where without the intervention of a host processor or microcontroller, they can determine the presence or absence of motion. One of the most common uses of activity monitoring is for system-level power savings. So in systems where power consumption is key, you're trying to minimize it, you're trying to extend battery life, for example. So the idea is that you have a low-power accelerometer that tells the rest of the system when to turn on and off. So the accelerometer is lower power than the rest of the system. It is on all the time and monitoring activity, and only, for example, when it's sensing activity, so when the system is in motion, does it tell the system to turn on. So I've got here a demo that is basically a mock-up of a system with activity monitoring in it. So it's got an accelerometer down here at the bottom, a PIC controller at the top, and in the middle an LED. And you can see that the LED turns on when I move the board, so when the board is sensing activity. And as soon as I set it still for a minute, the LED turns off. So it's on, and then it's off. One of the problems that plagues systems like this with built-in activity monitoring is erroneous turn-on events, so false positives, or when the system turns on when it shouldn't have. The issue with this is that every time the system turns on, it consumes power, and if that's what you're trying to save, that's not a good thing. So on the table here, I'm showing a competitive comparison. I've got two identical motion-activated systems. One is implemented with Analog Devices' new ADXL362, and the other with another accelerometer. The ADXL362 has an enhanced motion detection or activity detection algorithm in it, and the other accelerometer does not. So what you can see is that when I pick them up, when I move them intentionally, both systems turn on, or both lights turn on. And they both also turn off with inactivity. But when I say bump the table, or close a desk drawer on the other side of the desk, you can see that only the accelerometer that doesn't have the enhanced activity detection turns on the rest of its system. So every time I do that, this system with the other accelerometer is drawing power, where the ADXL362 system is not. The ADXL362 is a very low power accelerometer, but beyond that, it's also riddled with features that enable system-level power savings. To find out more about this accelerometer and its power-saving features, please visit analog.com/ADXL362. Thanks for watching.